In this video, I'm going to be going over a Peltier heat pump that is directly connected to solar without the intermediaries such as batteries and buck converters, with the exceptions that we'll get into a little bit later. And it is related to my previous video on how Peltier plates can be used as supplemental cooling and heating when directly connected to solar panels. As you see here, finished product first, we've got the heater and cooler as it stands, with thermal images kind of showing the performance-wise of the finished product. The main goal of this project was to take what I learned in the first project video about the Peltier plates and make it a more aesthetically pleasing design that I could use that would serve a practical purpose in addition to just kind of being a neat thing to mess around with. Specifically, to improve on the last design, I wanted to make a water reservoir for the waste heat side instead of an air exchange, which I found to be much more efficient in the long run when it came to getting rid of the unwanted heat or cooling. I also wanted to make sure that I could have the ability to easily swap between hot and cold. So in the last one, I had to unwire the thing and rewire it in order to get it to do the hot or cold that I wanted. In this one, I just wanted to use an easy switch to switch between the two. I wanted to try to use a water tower for the inside buffer temperature storage. I think it would look neat, and at the end of the day, I think I could have done this a little bit differently, and I'll get into that a little bit later, but initially my thought process was that it would act like a buffer for the storage. Optional but ideal would be that it would be quieter than the last one. The last one had just kind of a fan on some heat sinks, and the air turbulence in the fan was not exactly quiet, so I was hoping for ideally quieter. Another one was no 3D printing needed. I see a lot of these kind of projects where they start with simple tools, and then it just delves really far into this super specific custom parts. So I wanted to see what I could do without getting a 3D printer. In the end, spoiler alert, it would have been much easier to use a 3D printer, but for this one I just wanted to set myself that limit. I also wanted this to be an easily repairable thing, so a lot of times I kind of paint myself into a corner, metaphorically speaking, and use a lot of adhesives or things that are permanent, much more permanent than screws and bolts. So with this one, I wanted to go into it with the mindset of, if something breaks, I'm able to easily repair it in the future. Lastly, I wanted to use roughly the same amount of power as the lattice design. I wanted to use within about 10% of the power. I knew that I was going to end up using a little bit more, and that was okay because I did have some wiggle room, but I wanted to stay within that same ballpark. For my initial design, I thought I was going to try and use some bolts and nuts to wedge the plates in between the bolts themselves, so there'd be long bolts, and just kind of wrap it in insulation. I ended up changing this later, and I'll go into that a little bit later. I start with cleaning and testing each plate. I made the mistake of not testing plates before. Whenever I made that first design in the video I talked about before, I wanted to make sure each of the plates used about the same amount of power as the other ones, because when one of them uses significantly different power, that usually means it's probably something wrong with it. I wire them in series. I go into why I chose the 4 series design in the last video, but essentially, if I divide the voltage that I'm getting from the solar panels by 4, it uses the right amount of wattage. It's the balance between the amount of power it's using and the coefficient of performance, which is not great to start with, but it is better using those using Peltier plates at lower voltages, because it generates much less heat and is able to move more heat per wattage used. Me just using some protective shrink wrap to cover the contacts so it doesn't short it just on accident, and lastly, using some thermal grease to ensure that the heat transfer between the water blocks and the Peltier plates is solid. So here I'm making a sandwich of the Peltier plates, and if you're trying to replicate this at home, just kind of be careful with the orientation, as I'll show you in a second, and make sure that the hots and cold sides are the way that you think they are. I made the accidental mistake of using one of the sandwiches was the wrong orientation, so I ended up having to undo them, turn it around, so that way the contacts wouldn't bump into each other and I wouldn't be able to put the plates in the right orientation where the cold sides matched. So here I'm taking the insulation and just kind of doing a mock sketch of where these water blocks and Peltier plates are going to be sitting at. I take it, sit on top of the foam, and it's a tedious nightmare. of making sure that each side is even. Especially early in the process, I didn't want compounding mistakes to happen. Here you can see me setting the router bit depth to a little bit less than halfway. I did this with the idea that I was going to squish the insulation together to put pressure on the plates and kind of keep them in place. I used a pretty slow speed, and it was pretty easy to hollow out the core that the plates and the blocks were going to sit in. If you decide to do this at home, as with most foam insulation, you should probably open a door and turn a fan on at the very least. But I already have 6 credit cards in my body. What's 1 or 2 more? Here you can see me marking where the water pipes were going to be sticking out of. I ended up changing this entirely, and I was really vastly overestimating my construction skills and construction abilities in general when I thought that I would definitely be able to fit the tubings and fittings and stuff in with the foam still there. So I ended up just kind of slicing them off at the end, which is fine. I'm going to lose a little bit of heat from the top, but at that point when I got to where I decided I needed to cut them off, I just didn't care. I had to squish the foam a little bit. I really also vastly overestimated my ability to do a little bit under halfway, and it was a lot more under halfway for the router bit depth, but it worked out fine. So I'm assembling everything, putting it together, sandwiching it between the insulation. You get the idea of what I was trying to go for, where the insulation's on the top and bottom and around the sides. And I was using 1/4 inch acrylic. So I really shot myself in the foot here because I did not space it out, and I also didn't want to go out and buy extra materials. And so I thought to myself that I could definitely have the bolts touching the plates, water blocks, and all that stuff, and it wouldn't lose just a tremendous amount of heat, and the bolts that I had were definitely long enough, which was not the case in the slightest, as you'll see here in a bit. Here I'm drilling through the acrylic, the 1/4 inch acrylic that I had just kind of left over. I really should have just bought different acrylic or used thinner acrylic, but this is what I had on hand. I decided to kind of dry fit the thing because I couldn't get the insulation and the bolts to fit with the plates blocks in there at the same time, and this was just a lot of waste of time because the bolts just bled heat a lot. They were really close, and it was really just losing a lot of efficiency that I didn't really have to spare because I was too lazy to go buy a new sheet of acrylic. So the tedious nightmare of dry fitting is over. I'm just deciding and figuring out, hey, is this actually going to work, or am I just really not going to go this way? And I did the temperature checks, and the bolts were just really taking a lot of the heat away from, or bleeding heat out of where it should be. So I decided against it, and I needed that. A, I needed some longer bolts, and B, I should probably use a different piece of acrylic to do this. I finally decided to use some thinner acrylic and went and just purchased some longer bolts. And initially I sanded them to just kind of hide. Theoretically, I was thinking that I was going to maybe spray paint it and then use it to hide this disaster of a project that I had started. But in the end of the day, I went ahead, and it was additional housing that I decided on to keep all of this and the wiring and the tubing and stuff hidden. So the sanding was a little bit unnecessary, but it worked out okay. So this was a lesson that I already kind of knew before, but I just never thought it would apply to me again, is that when you're using really thin acrylic, so this was about 1/8 of an inch, you really want to have a solid backing, or otherwise this happens. So after recutting the piece that I broke, I used a better backing. I used 2 pieces of the 1/8 inch acrylic because I thought that this would help with the rigidity and help keep the plates sandwiched firmly between the 2 water blocks and insulation. And here you can see me just kind of re-drilling all the holes that I knew I was going to need. I used the old one for spacing width-wise, and just gave myself a little bit of extra room so I could wedge some insulation in between the two, between the bolt that is still going to hold everything in place and where the blocks and plates are. I also initially drilled some 2 bolt holes on the bottom, which I ended up not using at the end, and you'll see that in a little bit later. But here was a pretty nerve-wracking part, because if you haven't worked with Peltier plates before, a word to be wise is that they're pretty fragile. They're kind of sturdy up until the point they're not, and then they just crack and shatter. So I had to be very, very careful when I was squishing all of this together. If I unevenly put pressure on everything, one of the corners would end up cracking, and then it would really throw off the entire build as it stands. So this is probably the most delicate part of the entire build process, is making sure that I assemble everything in a way that doesn't put too much pressure on one side or the other. Also, another thing, if you're trying to do this at home, is that don't do it first and foremost. But if you decide to go ahead and do the insane thing and do it, make sure you measure pretty well whenever you're putting these sheets of acrylic and lining them up, because the bolt holes were very slightly off on 2 of the holes, maybe 2 or 3. And it was a nightmare to do because I couldn't really force them into place, because again, these plates are pretty fragile. But I needed the acrylic sheets to squish together and fit, so I just kind of had to slowly keep drilling out these. Also, the acrylic, which is pretty fragile, and trying not to have anything catch when it's drilling and then crack and shatter, and I have to start the whole plate over. But eventually, with enough cursing and perseverance, I was able to get the housing in place for the insulation and the water blocks. Essentially, like I said before, the foam is kind of acting as the bolts were acting in the initial plan, where it's just putting gentle but firm pressure up against the sides of the plates, and the other plates and water blocks are keeping the other sides in place. After inspecting everything, the place where I could see if I was kind of messing up was the top part where the tubes were going to attach. And if the plates were off-center, or if they were bulging, or if they were really, really sunk in, that's where I would know that I would kind of screwed up. Here you can see me using a ruler to make sure that the pressure is being distributed evenly. And so I'm using the bolts to kind of fine-tune the distance between everything, so I know that, yeah, this is going to be just as tight as the other side. So after fine-tuning and making sure that everything was about the right size, I then went on to do some temperature checks. So I would turn the plates on, and then I would just kind of put the probe just everywhere I could think of and see if there was a lot of heat leaking. In some places, there was some heat getting out. Some thermal images later do a better example of showing where the heat was leaking out, but it was much, much, much better than the initial plan of putting the bolts right up against the very thermally conductive bolts up against the things that are supposed to be moving heat around. I ran into my first hiccup of redoing the design on the fly of the acrylic plates bulging. I didn't think it was going to be as big of a deal as it is, but here you can see that they're very clearly bulging because the washers are putting pressure up against the sides more than the center. This is where, again, I kind of shot myself in the foot with not just buying the right acrylic from the get-go. I think that the 1/4-inch acrylic would have been perfectly stiff enough to not have to need additional support for bowing. But I went ahead and said, well, I'm just going to go ahead and put this into an additional housing unit anyways. I'll use that housing to help fix the bowing issue, and it'll give it a little bit of extra support, and it'll hide this monstrosity that I had created so far. I got a little lazy right here with the time-lapse footage. It was kind of a pain in the butt to do it set up for the desk part anyways, and for the workshop one it was even worse. So I made a box. It's got some grooves in it for the nuts and washers and bolts to slide in, And as you can see here, I'm just kind of like showing, hey, it's going to slide in there. I removed the 2 bottom bolts as I had said earlier, so that way it could just slide all the way in. And I was going to use the same strategy of put some insulation so it can like butt up and put pressure up against the bottom of the plates and water blocks. Here is where I also realized that I really overestimate my skills and ability to do tiny meticulous things, because the acrylic sheets were too tall, and so it was a pain to put the tubing in and put the clamps in and secure them. And you can see me go through this nightmarish process of trying desperately to keep the acrylic plates as long as possible just because I was too scared to cut another piece. And it was just awful. This is probably where I wasted the most amount of time on this project, trying to tube this. And the funny part is that I didn't have to do this in the first place. I was just trying to test everything where it was at, because I'm going to have to take all of this off, the tubing that I'm spending so long trying to get into place, and put it back on whenever I put it into the housing. So after this nightmare time lapse is finished, I began wiring the buck converter. This is what's going to power the 2 pumps as well as the fans for the radiator, the heat exchange part. This is just a cheap buck converter off of Amazon. It takes the solar panel voltage and turns it down to a usable level. This was that caveat I was talking about in the beginning of the video. The Peltier plates are directly wired to this solar panel, so they receive the full 18 volts and it's distributed amongst them and divided equally on the 4. But the fans and the pumps can't really take that kind of voltage, so I have to put it down to a usable level. And it also helps use less power just in general, because you can use these pumps and fans at a much lower voltage than they're rated for, and they just go slower instead of just not working at all. Here you can see me beginning to set up for the full-blown testing. So I'm setting up the 2 Tupperware containers to have the water that's going to exchange the heat for the hot and cold side. I start by wiring the double pole double throw switch. This is one of the goals that I initially set out for, to make it easy to swap between pulling the hot inside and making it cold inside, and just by reversing the voltage on only the Peltier plates. Friendly reminder to read the instructions. I screwed up the first time I wired the switch, and I'm not 100% sure how I wired it, but shockingly, if you just read the directions, it goes a lot better. After finally wiring it the right way, and by reading the instructions, I start by just kind of making sure nothing really leaks, or that the pumps and fans are wired the right way, as well as the double pole double throw switch. This was also a good spot to check and see how much power the pumps and fans were using. All told, it was a little bit less than 10 watts total, which was pretty good. Here we can see a little bit of a time lapse of the Peltier plates and pumps in action. This is just 2 Tupperware containers of water, and I just thought it was a neat little shot to get to visualize what's happening with the water inside. All things considered, it was working pretty well for these kind of smaller quote-unquote loads that it was trying to heat and or cool, or just move the temperature around in. I really wasn't expecting miracles again, because I know that Peltiers aren't really efficient. I just, again, really think that they're neat and cool to work with and super extra. But this is the smaller quote-unquote load. It was able to cool it off pretty quick. The time lapse was a couple minutes for this kind of stuff. This also gave me a good opportunity to check and see how well my insulation job was. It wasn't fantastic, but it was also pretty good, all things considered, and how many screw-ups I had along the way. And it gave me a chance to see how much heat was being bled through the tubes. Here you can see the thermal overview of what is obviously the cold side and the hot side, and the heat or cold being lost through each. The tubes and the tops are the worst parts. The sides aren't that bad. The bolts are showing up on thermals as super hot, but it's just reflective surfaces kind of mess with the thermal camera. So, but they were about room temperature, which was much, much better than the initial way that I was going to set it up, where the bolts were directly touching the plates. Eventually, the tubes could be improved efficiency-wise by just covering them with insulation, or getting some insulation to wrap around on the inside at the very least. But that's a little bit down the line. And then we have one last thermal after it's been running for a little while to see how much of a temperature difference it made. Again, this is the Peltiers running at what the solar panel voltage is going to be, so about 18 volts. So it's pretty interesting to see the pretty dramatic temperature difference. The abomination on screen that you see here is a quote-unquote dry run of how it's going to be wired. It's going to just kind of going through an overview of how it's initially going to be set up, but just is going to be organized and not look terrible. But we see the buck converter is being powered directly by the bench power supply, which is simulating the solar panels. The double pole, double throw switch is also directly powered to the solar panels, are directly connected, which is connected to the Peltier plates. I've got my reservoir tank on the right, and then my outside bucket of water is the waste heat location, and that's just simulated by the bucket on the left, which is just essentially just a smaller version of the real thing anyways. I had to justify this thermal camera purchase as many different ways as I could. So here you can see the setup for the process, just the initial setup and how it was going to work on thermal camera. Here's the setup running, just kind of a time lapse. I've sped up the footage a little bit, but the timestamp in the top right is where you can see the real lifetime that's elapsed. After running this, I realized I kind of screwed up again, which is a pretty common theme for this entire build. And I don't really know what I was thinking where I could just have a giant block of cold. I'm not really sure what I thought was going to happen, but after watching this run for a little while, the condensation was insane, which is good because it means it's working, but bad because I didn't design this to have any sort of way to deal with that sort of condensation, so I couldn't quote-unquote store the cold inside without just leaving a mess wherever it was stored, or I had to specifically design something to hold the condensation that was generated. So it ended up that I had to use a little bit more power at the end of the day because I had to add a radiator with fans to the cold side so I could dump some of that cold, quote-unquote, into the room and not have to worry about the condensation building up on the water tower. I guess for whatever reason I thought I would only condensate a little bit or just be able to deal with it, but it completely slipped my mind. I don't know why I thought I wouldn't need a fan or something like that. And like I said, as the text on the screen says, I could theoretically make just a big thermal mass to have a cold sink essentially into, but it would just be huge and it would be kind of a nightmare. So adding a radiator really kind of solved that problem. So only under super specific conditions does condensation kind of sort of become an issue with the fan added into the mix and the radiator specifically. And it's little enough condensation that the little tiny drip tray that I added to this housing catches everything and it evaporates before it becomes a real issue. Power consumption, like I said before, is a little bit above or around 10 watts with those extra fans added on and the pumps, but still within tolerance. Here was my initial location that I wanted to set this up on. I've got my proof of concept design that I did in the last video and the pipe that goes outside here. Here we see the housing unit secured to the wall with one of the 5 screws in a 2x4 stud, and the rest of them with concrete or drywall anchors behind it. We've dry fit the insulation housing into the housing itself, just to make sure it fits like I think it did. And then we have our leak testing of the pipes. This is one way that you can tell if a fitting isn't quite snug on the aluminum blocks for the water exchange. As you can see, like it kind of sucking and gurgling and it's pulling air out. And then after I took it off, tightened it up, cleaned up the connection, there's no bubbles anymore, so that's how you can kind of tell, oh, that leak was coming from there. I let this run for a bit just to make sure that, hey, nothing is just going to pop up over time and small seeps or anything like that build up. After this leak test, I crammed all the wires inside the housing unit. This is where I kind of should have left myself a little bit more space. It would have been nice to have a little bit more room to work with here. I used electrical tape to make sure that nothing shorted on itself, but overall I had just enough space, barely. And then another wet, dry kind of sort of test where I just plug in plumb everything up and make sure nothing leaks and it's doing what it's supposed to. The set was or the switch was set to have the hot being inside, which is fine because it's reversible. I accidentally flipped around, but I mean, whatever. That's the whole point of the switch. This was also a good time to check and see how warm the buck converter was going to get, because it wasn't pulling its full rated current, but it was pulling not an insignificant amount. So it gets warm, but it's not hot, which was my main concern. Here we have the radiator plumbed into the actual water tank reservoir, and I used a bus bar style to hook up all the stuff that was going to be on the buck converter with some Wago clips on the side that were just essentially hot glued to the side of the radiator. Would you look at that? More thermals. Who'd have guessed? Well, so I've got the thermals reading the setup after it's been running for about 5 minutes. Initial checks were pretty good. It was doing about what I thought it was going to do, in the sense that it was putting cold inside and it was taking the hot outside, which is what I wanted. And the tubes and wires kind of reflect what I'm talking about right now, whereas, you know, all the cold is inside. Here you can see me kind of like peeking through this small gap that, because I'm a crappy craftsman, you can see through it, and it was able to let me check the temperature of the buck converter, which was kind of nice because, again, it was making sure it wasn't getting too warm inside, which it wasn't, thankfully. I am a firm believer in continuing to test as much as I can before finishing up, because the amount of times I've had to undo something and redo it because I didn't check on something before I put the glue or final screws in is too high. So this is after it running for a little bit. You can still see the temperatures are still pretty good. Buck converter temperatures are still running fine, which is great. A colder day in March was a happy coincidence because it let me test the hot side of this Peltier plate heat pump, and it worked pretty well. It actually works a lot better as a heat source than it does a cold source, because the plates tend to generate heat as they stand, but they also do a pretty good job of pumping it over to the other side. So it worked great. It was probably is going to be more useful or more efficient in winter than it will be in summer. Minus the solar power availability in the sun and all that other good stuff. But like I said before, the insulation is going to be like the next step to improvement, but this was just kind of making sure everything worked the way I thought it was going to work. So probably just as important as the inside setup is the outside setup. I've got two 100-watt panels in the backyard that are just kind of propped up. Technically, this panel or this setup works with one, as it only draws like 70-ish watts. But the second panel came in a 2-pack, so I just figured, I'd just hook them both up. They're both 100-watt panels that give about 18 to 19 volts, not short circuit, 22, 21 volts short circuit. I ran them wires and taped them a whole bunch to protect it from the elements in general. And then I've got these two 55-gallon drums, as well as the hole where it goes inside of the room. This is the waste heat or cold, depending on how I'm running it, where I will be kind of using it as the heat exchange for the waste heat side. The two barrels are filled with water and leveled with that pipe that runs between them, and the tubing from the pump that's suspended in the first barrel, as well as the wires wrapped up in that white tape, and then the wires from the panels are kind of like merge into the insulation sleeve that goes into the house. Another reason I chose this way is A, I can get away with it because it's in the backyard, and so people don't know I'm a crazy person unless they go into my backyard. And B, it also kind of serves as an emergency water storage. I just have to clean it out every couple months, and then it's kind of like a reservoir of water just in case something happens. The word finishing is being used pretty generously here, but I put a brace in so the bottom radiator and the water tower wouldn't get like knocked off. I tried to add some glitter dust, but I changed that later, and I'll show you that in a little bit. Here's a peek at what's going to be underneath the upper housing. I put some insulation on the top of the reservoir, as well as the tubes are connected, and they kind of go through the reservoir to the radiator. I used basically another wooden box to hide everything so it wouldn't look as hideous. And then here's everything before I changed the water coloring. The glitter didn't really work out. Here, everything is running directly on the solar panel. The panels are voltages are about 21.5. I've got some radio connectors and the multimeter hooked into it. I'm using a bench stock supply here so I can kind of show and visualize the voltage and amperage of what's actually being used, and as well as the power usage with a multimeter to check and make sure it is what it says it is. Wattage was around 71 to 75 watts, which was still within the goal that I'd set myself initially, and a little bit higher because it does use another pump as well, versus the first setup go around. But overall, I was pretty happy. It used about the goal limit power that I initially defined. And here's why I made the optional goal of being quieter. As it stands, there was a lot of turbulence from this fan just being set on the radiators. So this was the new one, and it was much, much, much quieter. Mostly just because the fans were running slower, I guess, but it was able to still move as much heat as the initial one. And a cat. And here we have a working overview of it as it stands. It's more or less finished here, minus the decorating around it part. I have a lot of plans to like make this part of a stand or of like some sort of place to hold clothes or something like that. So that's why it kind of looks so wonky and out of place. But we've got the wires set up and they're kind of tucked up underneath the backside of it. There's a small gap between the housing and the actual house wall. And then I tucked all the wires kind of back behind it. There was a small plastic tray that dealt with any sort of leftover condensation, but never really got bad enough to where I needed it on a regular basis. Double pull, double throw switch to make sure I can switch between hot and cold. I'm just going to kind of breeze over these. You can pause them if you want to read them in their entirety. Of some of the last final thoughts, issues, and stuff I had along the way that I don't know if I mentioned earlier. Initially, like I said, I know I mentioned this one. Condensation was a huge issue initially until I added the radiator with the fans on it. If I scaled this up, then I would have to have some sort of permanent solution to this other than just a tray to collect all the oopsies and the leftover bits and bobs of the condensation that might build up on those hyper-specific conditions. But really, for such a small, it's less than 100 watts. So I touched on this earlier, and man, I really cannot stress enough how better this probably would have turned out. I don't think it turned out bad, by all things considered. But it would have been nice to have the things that I needed and just bought them instead. Spending $20, $30 on a sheet of acrylic, like the 1/4-inch sheet, would have been great. And then I wouldn't have had to deal with the bolts as well as the wooden housing, which, it ended up being okay because it was a place to put the radiator and a place to put the water block. But it was oh man, that was convenient, not I definitely planned this ahead of time. And short of me just, admitting it right there, who'd have known? So, it's whatever. Not bad. Not great, but not bad. I'm sure at some point I'm just going to break down and buy a 3D printer because the amount of times I've had to cut weirdly specific shapes and hyper-specific tiny things for the stuff I'm doing is more than I'd like to admit. And I've been making do for a while, but I was like, man, I can probably get away with not using the 3D printer. And I could. And it would have been a lot better had I had, the materials that I initially wanted to use versus what I just had on hand. But eventually I'm probably just going to end up breaking down in multiple ways, but specifically in this way, just buying a 3D printer. Some of the smaller issues that I had that weren't huge, but just things I didn't really anticipate. I mean, I didn't anticipate any of these problems, but these specifically were just like, I didn't think that was gonna it wasn't even on my radar, was planning the aesthetics ahead of time, because the water tower and fan placement, like I said, was just something I was like, oh man, I could just throw it on top of the housing. Heck, all right, cool. It could have been probably a lot smaller and a lot less bulky and blocky looking. I don't hate the way that it turned out, but it was just something that could have been planned for. But, knowing, obviously, hindsight's 20/20. The pumps I have are a little bit more noisy than I'd like. I've been tweaking since making this video with the pumps, and they're much quieter than I thought, but using some better, higher quality pumps would go miles. These were just the cheapest bulk-ish quality pumps that I found on Amazon. They were like, I don't know, 10, 12 bucks for 2 of them. And I've used them for other things, and so I was just like, yeah, I'll just use what I got. And it worked, but because they're designed for 12 volts, but you can run them lower, and they work, but they're not just as good. But like if you pinch the tube, or if there's any sort of stress on the pump, then it's not really, it kind of like makes a grindy sound. It's not great, but not terrible. But as it stands now, it's quiet enough, and it's still much, much quieter than the initial design. This was one of the more disheartening ones, where the glitter thing that I tried to do didn't work. What I wanted was some sort of like lava lamp effect, and what ended up happening is that I just had to keep adding more and more and more glitter, and it got to the point where I was like, man, I'm gonna clog the radiator fan vents at this point, or just screw up the pump. So I was like, man, I don't want to keep adding more stuff to it, so I just settled on dyeing the water black, and eventually I could dye it a different color if I wanted to, but black just kind of hid the pump that's hanging halfway down the radiator reservoir block of water. But I don't really know how to get it to continue to circulate inside, because it just kind of sticks to the side of the glass, which is annoying. And I even like tried to add like angled water jets from the outputs and inputs and reposition the pump a half dozen times or dozen times, and I could never get it to continue. So like when the sun goes down, everything shuts off and the glitter settles to the bottom, and then so a little bit gets kicked back up in the morning, but it's not like the full force, because a lot of it sticks, like I said, to the side of the glass, probably to the inside of the tubes, inside the radiator. So the more and more glitter stuff I added, the worse and worse it would probably get. I was probably using, again, the wrong stuff, because that is a theme in this video of just using what I had. So I used some like food coloring glitter. It doesn't really do great dissolving in water, so that's probably some issue with it. There's probably some super hyper specific thing that I could have used, but yeah, it's fine. And lastly, this was a kind of a goofy, oopsie, forget thing. The fans don't turn off ever, as well as the pumps. So like on very hyper specific conditions, such as it's super, super cloudy, but it's still day, they'll have enough power to run the fans, but not the Peltier plates. And so I didn't put a power switch to turn everything off, which was really dumb. And it would probably be an easy fix and something I can take care of later when I build the shelf housing stuff around where I put this radiator. But for right now, I mean, I could just unplug the panels from the Wago clips I've got there. But it was just something I didn't think about until I got finished. And I said, oh man, I can't turn the pumps and fans off. And if it doesn't have enough power to run the plates, the pumps and fans oftentimes still just run. So, eh. And so for final thoughts, I'm pretty happy with how this turned out. It's a practical use for the Peltier plates as a heat pump, because it's directly powered by solar, which I just think is the super coolest thing. Again, I know it's not efficient. I know that there's 1,000 different ways to do this probably that I didn't think of. But like I touched on in my last video, and the reasons why I didn't go with a condenser-based system is, and the spoiler is that I'm not competent enough to do that. I feel pretty good about this. All things considered, it's still pretty neat. It's free, cooling, essentially. Well, it's very expensive free cooling, because I spent a lot of money on the initial parts and stuff in the last video. But for this video, I just had it all laying around, is what I like to tell myself to justify I do a lot of mental gymnastics, just gonna put it that way. Works out pretty cool. I think it's just neat. It was just a neat thing, and I wanted to go over the build and how I just kind of did this, just in case anybody else is ever looking for this kind of stuff. They can see this, what is now pushing 40 minutes of video, 35, 40 minutes of video, and skip to the parts that they want. Regardless, I hope at least some part of this video is useful to whoever is watching. If not, at least I hope it was maybe entertaining. If not, I admire your patience to watch really dumb things, I guess. And I'll see you in the next one.